Welcome here to the SEAM studio, ladies and gentlemen. And this time around we're going to look at a little bit more in the flying techniques, helicopters, but let's go to the mountains. And there's going to be 5 presentations, and this is going to be the first of the 5. Right, in the introduction, just to say the only effective mountain rescue aerial vehicle, and that's just a little bit of a tongue-in-cheek, I suppose, to manage the chopper, especially when required to uninhabitable geographical locations. And that is quite true. So just to make us feel good there. And then the series on mountain flying by no means contains all the knowledge of the mountain. Never think that we've got all the knowledge. But serve one well in procedures followed, and discipline as well as common sense must prevail. Right from the outside, the mountain is not your friend. The sea is not your friend. The sky also cannot be your friend at times. But the mountain especially is one of those places where you must know your place in nature. And this all is going to be how to enjoy our place in nature. Right, so in the scope, there's a couple. I'm going to look at restrictions, planning and procedures, density, altitude, power available, weather, and then there's a little bit on mindset as well. Now, remember, I'm breaking this all up in a few. We're going to look at all the difference, and I'll give you a scope as we go on with each section. Okay, so without further, let's look at the restrictions. A maximum operating altitude of your particular helicopter, as well as the minimum temperatures of operations, are to be adhered to at all times. Know your machine. That's quite effective. Then, when flying at altitude, the following are to be borne in mind. Okay, no flying is carried out above 13,000 feet above mean sea level without the use of oxygen. And remember, here we talk about what is prescribed by ICAO, and that will be on the civil aviation. It will be part of the regulations, and in certain cases there will be technical standards applicable as well. Okay, the total time above 1,000 or 11,000 feet is not to exceed 60 minutes. V&E, velocity not exceeded, and the CP values, collective pitch, must be calculated and adhered to. Right, again, look at what is happening in your aircraft handling notes. Excessive angles of bank will cause blade stalling and a rapid indicated airspeed decay. Wow. Excessive angles of bank. Park brake, where applicable, is to be on during the whole sortie. Whoa, what are you on about here? Not all the helicopters are skid equipped, some are wheel equipped, and the last thing you want to do is to land on the side of a mountain and you start rolling all over the place. All right? So once you get into the mountains, park brake on. For those with wheel, skids, don't worry, the skids will do what skids do. Great, let's have a look at planning and procedures. Well, first of all, we're talking about planning must satisfy the following. Now let's just go through each of them at this moment. Define sortie profile. What is it that you want to go and do in the mountain? Where do you want to go and do the mountain? What is the purpose of the flight? Is it just, we don't just bomb in and bomb out, okay? So there must be, what's the reason? I mean, what are we going to do? And where we could go? In other words, there's quite a bit of planning, because the weight changes due to the drop-off and pickups. That must be helicopter performance at the different altitudes. Very important. The influence of limited fuel on the sortie profile, because many times we're a little bit too heavy to go and land at 10 or 11,000 feet, and then all of a sudden we take minimum fuel, which obviously will bring down the amount of time of the sortie. This needs to be considered in your planning phases. Weather conditions, that is a tough one. Man. The one thing about the weather is that it can change, well, without notice, all right? That's like one of those givens. Have you got the emergency gear on board? And what about this emergency gear? I mean, really, I'm not going to camp out in the mountain. Well, that's not the plan. Should anything go wrong up there and you need to land, you must be able to survive. So a precautionary landing in the high mountains will very, very quickly get into a survival condition. And you can have the water and you can survive. And you can have a few chocolates and you can survive, but you're going to freeze to death. Or vice versa, and the combination of anything of the above as you wish. Flight following is a good idea. Somebody must know where you are. I need to just reiterate that. When you go mountain flying, somebody must know where you are and when you are supposed to be where. All right? Somebody must come and look for you if you're not coming back. But they must know where. All right? So don't just fly off into the mountains. I just want to go and do the solitary thing all by myself. No, that's nonsense. All right. Passengers, surely they must be briefed. And that's pretty much standard. Influence of density? Well, let's just see. I'm just making the statement here. Density is influenced by what? Okay, the higher we go, the thinner the air becomes. But the higher the temperature, the thinner the air becomes. The more humidity is present, the thinner the air becomes. My goodness. So everything can make that the air is less dense air, well, with the same power application, the same everything application per height, your performance will become less. All right. So what is it then? The higher up the mountain, the lesser the density. Great stuff. The higher the temperature and humidity, less the air density. We've got that. The lesser the density, the longer it takes to slow down. Oh, there's a new one. All right. So we want to land here, and here we come in with the chopper, and there goes the landing spot, because all of a sudden we've got to use higher altitudes to stop. Higher altitudes to stop at high level where there's... Just think of high-level flying as flying at maximum all-up weight. You can't just maneuver. You can't just stop. You can't just overpitch. There's a lot of things you can't do. All right? So we pay attention, and we say in the thin air it's quite possible to initiate an unwanted rate of descent. Now, an unwanted rate of descent is an acceleration, and to stop any acceleration you need energy to stop it. All right. So now all of a sudden you've got a rate of descent. How are you going to stop it? Oh, I'm going to bleed the speed. All right, cool. You're going to break the speed, but there is going to be collective needed as well. These things can happen quickly. So once you're at altitude, once you're at height in the mountain, then you have to pay attention to the performance, and very close attention. Power is less due to the increase in altitude. Power requirement to hover at altitude could be more than is available, and this is the whole thing. Everybody goes in. You can land on the top of the mountain. I can teach you to land with a helicopter on top of the mountain, and you will walk away and everybody will have fun on the top of the mountain. The problem is when you want to start up and get off the mountain, you ain't going to have the power, because the profiles that you're going to use is different. Now, obviously we can go through a couple of tips here, but they're not all for the faint-hearted. Let me retract that. I'm not worried about the faint-hearted. I am worried about those that really haven't got the skills, but they've got, they think they can. There's no space for bloated heads in that thin air. It absolutely has got no space. To arrest the rate of descent would make more than normal power. All right, we've said that. The onset of vortex extreme state is much easier. All right, so you can't get yourself into that setting. And I say here, a rate of D is limited to 350 foot per minute, as in coupled with the wind power available. The most important limitations on the helicopter maneuverability. Whoa, you've heard me talk about rate of descent before when it comes to getting yourself into a vortex ring state. To get into a vortex ring state, you need a higher than 800 feet a minute rate of descent, and you need the air from the bottom through the blades to be quite a bit more, to basically stop the downflow through the blades, and therefore the blade angle and the pitch angle becomes the same, and that means that the angle of attack at the root of the blade is too big, and an end. Alright, so it stalls from the inside out. Don't want to recap that. I just want to remind you that to avoid that, 350 foot a minute. Yeah, but I've learned 500. Yes, 500 foot is fine. I normally will say you try for 350, it increases to 450, 500. I put a little bit of power, the rate of descent, I can arrest it and keep it stable and reduce it. But once the rate of descent has gone the path, you better start breaking off the maneuver that you're busy with. Power available. Now just a little bit here, for those that don't believe it, but here you can see we on the ground, okay? And I didn't turn this up, it is really at 9,000 feet. You can see the engine power is turned down there, but the engine is still running, and we're sitting at height. That meant that we landed at 9,000 feet. Now I'll just say it again, it's easier to land at 9,000 feet to necessarily take off from 9,000 feet with exactly the same weight. Just because of technique and a couple of things that will happen. But alright, you mustn't be caught in the middle of those. Specifically, you mustn't be caught up in the middle of the berg on top there and you can't go anywhere. Helicopter weight is the main factor in the performance at height. Weight. Everything goes about weight. Alright, minimum fuel, not too many people, not too big people. Consult the POH and helicopter performance graphs. That is quite important, and straight level, that is why they are there. Fuel must never be more than the required, as the unnecessary increases the weight. Just listen to this one. Sometimes we've got helicopters that's got all the power and we've got all the glory and all that kind of. Any mountain, any height makes any helicopter humble. All right. So don't think because you've got in your Super Puma so much power at ground level and at coast that you can always have full fuel. At 11,000 feet, your weight is so limited. So you can either take something useful or you can take the fuel along. But you can't take both. All right, think about that one. Okay, then ensure the helicopter VNF for different altitudes as per helicopter performance graph. This you will find there. And remember the VNE changes. And you've got to seriously remind yourself to keep to that. Helicopters in high areas are seriously affected by VNE and should never be ignored or exceeded. Should probably put that in red so that we can pay more attention. Well, just here in the background, we've got this beautiful background of the mountains flowing in the back. Beautiful. And you can see the weather on top here, and that is where I want to go with this slide. The mountain weather can change rapidly. Fly early morning or late afternoon for the lightest winds. This is probably not a bad suggestion. We used to go to the mountains and then we would be the first birds up there. In the summer, hey, 5:30, we're airborne, we're into the mountain. 6 o'clock, we're up there. 6:30, 7 o'clock, 8 o'clock. Then the temperature starts changing, the winds starts coming up, and whatever will develop. Late afternoon, same story. Everything is like calming down, and it's like nature is taking a little bit of a rest. Not always, all right? But it turns out to be probably the better times to do things. What is your mindset? Now, I say it's not guaranteed a go. what I'm saying is here, you can't say, look, tomorrow morning we're going to fly and that will happen and that's the end of the game. Tomorrow morning if you get up and the weather is not right, you stay right where you are. There's no must. I understand that we must eat and we must do other bodily functions and stuff like that, but the one thing there's no must in survival is to fly in bad weather. I know that if there's rescues, we're going to fly in more tough weather. But when we start doing mountain flying, you're not going to, on your first sortie, be the rescue champion in the mountains. It takes time. All right? You must be able to read the mountain, and you must be able to gel and understand. You must be able to see the wind. No, you don't understand what I'm saying. You must be able to see the wind and what's the wind doing, but we'll talk about that just now. Check on the forecast as approaching the mountain, check the weather. If it's too misty, too cloudy, to whatever, then turn back. There's always another chance. The chance is to turn back. If it's too late, then you've got no chance, all right? There's no must in mountain flying, even if others' lives are on the line. Dead helicopter crew can't save a soul. And then you'll say to me, yeah, but surely, you know, really. I say, yeah, guys, really. Remember that we're not playing for the cameras. We're not playing for 15 seconds of fame. This is a real game. We're playing with Mother Nature. The mountain is not your friend. The wind does not care about you. You need to have the ability and the understanding, because no mercy will be shown if you do not adhere to the basic requirements. Until the next